Here's a list of polling locations in San Francisco. Now, given this list, if I asked you to make a new list that only included locations with the ballot type set to 20, in other words, elements like these, how would you go about handling this? Or how about this? What if I asked you to count the number of locations by ballot type? In other words, taking this list and transforming it into a map where the keys are the ballot type, and the values are the number of locations that use this ballot type. Or how about this? What if you had a list of numbers 1 through 5? How would you sum all these numbers together? There's a pretty good chance many of you thought about using a loop, like a for loop or a while loop. But here's the thing. Elixir doesn't have loops like you'd find in most popular imperative languages. So do you have any thoughts on why Elixir doesn't have loops? Well, the main reason is that you can't have a loop without... Can you fill in the blank here? To help answer this question, let's consider how you might use a for loop in another language, just to point out what the problem is with loops in Elixir. Take a moment and look at this code. Basically, this code uses a for loop to sum each number in this array and store the result in the total variable. Do you see anything about this snippet that just isn't compatible with Elixir? Well, what about this, incrementing I? This is essentially mutating or changing the state of I. And what about right here? The total number is being mutated as well. Mutations and other types of side effects are inherent to loops, as you see here, and of course, everything is immutable in Elixir, so what you see here and here just wouldn't work in Elixir because you can't do mutations like this. So to answer this question I posed a moment ago, you can't have a loop without mutations, and since there's no mutation in Elixir, there's no loops in Elixir. Now, as a quick side note, Elixir does have a feature that uses the for keyword, but it doesn't work like a traditional for loop in most languages. We'll go over what Elixir's for keyword does in an upcoming video. So how would you do something like this, totaling a list of numbers in Elixir? Well, I'll show you one way right now. So we've got a list of integers here that we'd like to sum together. I'd like to write a util module with a sum function that gets passed a list of numbers and returns the total. This module and function don't actually exist, but we'll create them right now. So I'll create the util module. Then inside our new module, I'll create a sum function that takes a list. Now I'm going to do the actual work of summing our list in a private function we'll call a doSum. In the private doSum function, I'm going to use pattern matching for lists, which we looked at many videos back. More specifically, what I'm going to do is set up a pattern match for a list parameter, and then I'll separate the first element of the list from the rest of the list. Now, the first element of a list is called the head, so I'll bind the first element of the list to the head variable. Next, I'll use the cons operator, followed by the tail, which again is a list that includes every element except for the first element. The first time this doSum function is called with this list, the head variable will be bound to the number 1, and the tail will be bound to a list that holds the rest of the numbers, the 2 through 5. So what kind of operation are we wanting to perform on the 1 that's bound to the head variable? Well, addition. We want to add the 1 plus the 2 plus the 3, and so on. So how about we do this? I'll take our head variable, and I'll add it to the result of calling the same doSum function, but this time I'll pass in the tail. What we're doing here, by calling the doSum function from within the doSum function, is called recursion. Okay, so think about the second call to the doSum function. It's getting past a list with the numbers 2 through 5. So this time, the 2 is bound to the head variable, and the list 3 through 5 is bound to the tail variable. Okay, you're probably starting to see the pattern here. our doSum function is going to get called over and over again until the list is empty. But for the moment, let's focus on the iteration where the doSum function is called with just the last number in the list, the 5. So in this scenario, the head variable is bound to the 5, but there are no remaining numbers. The tail is essentially an empty list. Let me ask you this. If we call the doSum function with an empty list, will this pattern matching expression right here work? Well, remember, pattern matching is in part an assertion, and in this function clause, our assertion is that doSum is getting passed a list which has a head. In other words, it's a non-empty list. So if we pass in an empty list, this function clause won't get called, and since it's the only doSum function clause, we'll get an error because Elixir doesn't have a doSum function clause that can handle empty lists. So what should we do? Well, we just need to write a doSum function clause to deal with an empty list. So I'll add a second doSum function clause that matches an empty list. And now the question is, what should this function clause do? Well, what's the sum of an empty list? It's 0, so we can just return a 0. Okay, I think we're done. Well, let's see if it works. But before we run it, I'll go ahead and take the result of calling our new sum function, and I'll pipe the result to the IO module's put function so we can see the resulting number. Now we'll go ahead and run our script, and the result we see is 15, which is the correct total. Cool. There's a pattern to how we solve this problem that I want you to recognize, because if you understand the pattern, you can use the pattern to solve other problems with recursion. Let me explain. There's a way of describing these two functions that we wrote. This function clause that matches on an empty list is called the base case. The base case is the function clause that interrupts the recursive function calls when recursion is no longer appropriate. In our example, the base case is when we've dealt with every number in our list, thus we're left with an empty list. Now, this function clause can be called the recursive case or the reduction step. When this function clause is called, there's still work to be done, thus the recursive function call here. So let me share with you a way of approaching problems with recursion. You've got to do two basic things. You've got to handle the base case, and you've got to handle the recursive case. Let me ask you this. Does it matter which one you handle first? Well, not really, except in practice, I suggest you handle the base case first. Why do I say this? Well, depending on the problem you're solving, if you forget to handle the base case, you may have just created an infinite recursion, which is kind of like an infinite loop. It'll likely crash your app or cause other significant problems. So generally speaking, I like to handle the base case first to ensure I avoid infinite recursion. After I've figured out and handled the base case, I solve the recursive case or cases. Solving the recursive case typically involves taking some small part of the problem and figuring out what to do with the small part of the problem in relation to the rest of the problem. So for example, in this function, which is the recursive case, we took part of the problem, the first element in the list, and we said we should add it to whatever you get by calling the same function with the rest of the list. Now our sum function works, but there's an issue with our solution that could cause serious problems, and that's what we'll look at in the next video.